Hello, this is Mrs. Grosch, and the topic for today's lecture is Introduction to Meteorology. When you think about a meteorologist, you probably think about someone who tells you what the weather's going to be. And it's true that that's a lot of what meteorologists that you see do, is they predict the weather. But really, a meteorologist is someone who studies the atmosphere, and they can study all different parts of the atmosphere. It's just that the part that's most important to us is the troposphere, and that's the lowest layer, the layer where pretty much all weather occurs. Now, what is weather? Well, you know what the weather is, but the definition for weather is the conditions of the atmosphere at a particular place and time. And so when we talk about what's the weather going to be tomorrow, we're really talking about the conditions of the troposphere that might affect us in terms of how we dress or the activities that we can do. Now, the atmosphere is made of air, and air is not a single gas, it's a mixture of gases. The recipe for air, what it's composed of, is, well, it's actually got oxygen in it, of course, we need the oxygen, but most of air is nitrogen. Nitrogen is a gas we don't really use very much, but it's about 78% of the air that we breathe. About 21% of the air is oxygen, and that only leaves 1% for all the other gases that you can find in the atmosphere. That includes the gas carbon dioxide, which is an important gas and really has an effect on us, but it's just a very, very tiny fraction of all the air in our atmosphere. When we talk about the weather and how the weather changes, what we're really talking about are some different measurements that we can make of the air. The air's characteristics can change, and here are some things that we measure to help tell what the air and the weather is at any particular time. One thing I'm sure you're already familiar with is temperature. So when it's a hot day or a cold day, we're really talking about the temperature of the air that's around us. And temperature is just the average amount of heat energy that's in those air molecules. The tool that we use to measure it is probably familiar to you. It's called a thermometer. And temperature is important not just because it affects how comfortable we feel. It also can affect things like air pressure and humidity. For example, air that's cold tends to be heavier and have a higher pressure than air that's warm. And warm air can hold more moisture in it than cold air can. Speaking of moisture, what we're really talking about is humidity, which is the amount of water vapor in air. Now, water vapor is water in the gas form. So water vapor enters the atmosphere when water evaporates, usually from lakes and oceans. And that water vapor can stay in the air until the air is so full of water vapor it can't hold anymore. When it gets to that point, we say that it's saturated and it has 100% humidity. We measure the amount of humidity in the air with a tool called a psychrometer. And when you get up to 100% humidity, well, the air just can't hold any more water vapor, so it begins to leave the air as precipitation, rain or snow or fog, and that happens when it turns back from water vapor into water in a liquid state. Something else that we can measure about air is air pressure. Air pressure is how heavy the air is. And even though you don't feel it, on average, the air pressure at sea level is about 1 kilogram for every square centimeter of surface area, which means that for every inch, you feel about 15 pounds of pressure pushing down on you. That's just the weight of the air molecules from the atmosphere that's on over your head. We measure air pressure with a tool called a barometer. There's lots of different types of barometers, but the one that you see in the picture kind of explains how it works the best. The picture shows a tube that's got a liquid, usually mercury, in it, and that tube has a base that's open. The air can push down on the open liquid, and as it gets pushed down by the air, it goes up in the tube. The more it goes up, the more it's being pushed by the air pressure. And so that means the higher the level of the liquid, the higher the air pressure is. That's basically how a mercury barometer works. People pay attention to air pressure because air pressure is affected by temperature and also by humidity. And those differences in air pressure can cause wind. When you see the air pressure change, especially when it changes fast, it usually means that there's going to be a big change in the weather. Something else that might tell us that weather is about to change is wind. Now, wind is really just moving air. And what happens is the air moves from an area of high pressure to an area of low pressure. How fast the wind moves is measured with a tool called an anemometer. When air moves from high pressure to low pressure, it probably means that one air mass, which has a certain set of characteristics, is going to get pushed around by a different air mass with different characteristics. And that's a way that we know that the weather will change soon. Something else that can produce winds are convection currents. Remember, convection currents are when something that's warm rises and something that's cool sinks, and it forms a circular pattern. Here's a picture showing a convection current where the ocean meets the land. You can see that the warm air gets pushed around by the cooler air, and it makes a circular pattern. This helps to explain why it's usually so breezy at the beach, because the wind is moving in a convection current. A lot of the characteristics that we measure about air are really based on heat, how hot the air molecules are. That can affect a lot of other things about our weather. So, where does the heat in our atmosphere come from? Well, pretty much all of the Earth's heat comes from the sun. The sun produces heat and other kinds of energy as well, and those types of energy travel to Earth as waves. We call this movement of heat and other forms of energy through space, we call that radiation. Once the sun's energy gets to Earth, some different things can happen to it. When the sun's energy gets to Earth, a lot of it gets absorbed, either by the atmosphere itself or by the Earth's surface. But some of that sun's energy, the radiation, gets reflected back into space before it even really gets to us. It might get reflected back by clouds in the atmosphere, or it might get reflected back by a shiny surface on Earth, for example, on the ice caps. Once the sun's energy does get to Earth, a lot of it stays here because of something called the greenhouse effect. Our atmosphere acts kind of like a blanket. It surrounds Earth and it holds heat in. It's actually not a bad thing. If we didn't have an atmosphere to hold in heat, we'd all freeze to death at night. But some people are worried that as the chemistry of our atmosphere changes and we have more gases that are really good at holding in heat, it's affecting the temperature worldwide and changing climates. We'll actually talk about that more in a future lecture. But for now, you know some things about the atmosphere and the different things about the troposphere that we can measure that help to affect our weather day by day. That's the end of this lecture. Thanks for listening. I'll see you in class tomorrow.